Hello, everyone. Mr. Waz here, and welcome to another episode of WasleyScience. In today's episode, we are going to be discussing the carbon cycle. So be ready to talk about CO2, oxygen, decomposition, photosynthesis, respiration, and much more. Let's say hello to our favorite element, carbon. Carbon is one of the main ingredients of all living things. The other things include nitrogen, oxygen, and hydrogen. So all living things are made up of carbon, oxygen, hydrogen, and nitrogen. If we look at this diagram in the bottom right, we can see that 18% of us is made up of carbon. Most of us is oxygen. Our neck is made of nitrogen. No, that was a joke. Our neck's not made of nitrogen. It's just a diagram that kind of makes it look like our shoulders are made of hydrogen and our neck's made of nitrogen. But 3% of us is nitrogen, so the least amount of us is nitrogen. Most of us is oxygen, and then carbon and hydrogen. Anyway, carbon is a versatile element. That means, the word versatile means that it can bond with just numerous types of other elements and in so many different ways because it has 4 valence electrons. Valence electrons are the amount of electrons on the outside shell. So carbon has a total of 6 electrons, and you can see in the diagram in the middle here, those first 2 electrons hang out in the first shell, and then the last 4 hang out in the second shell. And that carbon wants to have 4 more electrons in that second shell in order to feel stable and full. So it can bond with many different types of many other elements. Mostly it bonds with hydrogen and oxygen and nitrogen, but in just different ways because they form covalent bonds. And when you form covalent bonds, that means that you're sharing electrons rather than giving and taking electrons. And in addition to that, they can form double bonds and triple bonds. There's not really that many things in the world that are pure carbon. Diamond and graphite are examples that are pure carbon, but most things that have carbon aren't pure carbon. They're just, so many different other things that encompass all the living things on this world. I got news for you. So the carbon cycle is kind of a big deal. It provides oxygen for us so that we can respirate, and this maintains life. Plants use the carbon from the organic material to create oxygen. Carbon dioxide, CO2, is in the atmosphere. This traps heat in the atmosphere and maintains a temperature to sustain life. Without carbon dioxide in the atmosphere, the world would not be warm enough all the time to sustain life. And we would just be extremely cold whenever the sun would go away, and then extremely hot when the sun would come in. You can have too much carbon dioxide as well. Venus, for example, is even hotter than Mercury, even though it's the second planet from the sun. It has so much carbon dioxide that it traps too much heat and can't sustain life because it traps so much heat that the temperature is so darn hot. But we're lucky enough that we have just enough carbon dioxide to sustain life. And just to make something extremely clear, carbon dioxide is not a pollutant, which the news will sometimes say. It's a greenhouse gas. It's very important for life. It's very important for Earth. So here's the following things that we are going to be talking about for the rest of the video. All of these things are associated with the carbon cycle. They are all steps, and you can see in the diagram over here, we have photosynthesis, we have respiration, decomposition, we have combustion, and we have weather in rocks, which, well, it's not in this diagram, but we're going to talk about it. So let's get going here. All right, so let's start with photosynthesis. It's an energy transfer that you should already be pretty familiar with. It's when you take the electromagnet or radiant energy from the sun, and plants convert it into chemical energy. And to do this, they require carbon dioxide. They also require water, nutrients, and the sun's rays. But what's important here is that plants are doing a very essential part of the carbon cycle. They are taking carbon away. They are absorbing the carbon. So in this sense, we don't have carbon dioxide just keep going and going and going to the atmosphere, which would make us too hot. It's thanks to the plants that take the carbon away that keep this cycle balanced. So carbon gets removed from the atmosphere, and in this step, carbon gets absorbed. And when animals eat the plants, they store the plant in their body. And this is how chemical energy can get passed from plants to herbivores. And then you know what happens after that. So if you look at this chemical equation in the bottom left, this is very important, and you will see things like these chemical equations on the test, so it's good to become familiar with these. You have carbon dioxide, CO2, plus H2O water will yield us sugars and oxygen. And during the process, you have to have the sun's energy and chlorophyll. And what chlorophyll is, it's just what plants are made of. It's the green plant cells that they're made of, and they will yield us sugar, which is C6H12O6, and oxygen, which is what we need to breathe. Now, phytoplankton are the little tiny single-cell plant organisms that exist in the ocean, and they undergo photosynthesis in the water. And it's a misconception that trees remove all the carbon dioxide. It's really the phytoplankton that do most of the work. And if you don't believe me, think about it for a second. The ocean encompasses 70% of the earth. Land is only 30%. And think about how much of that land actually has trees, especially at this point in time with deforestation. The ocean is covered with phytoplankton, and they are the ones that are doing most of the dirty work. They are absorbing the carbon dioxide from the atmosphere, and they are converting that to oxygen, releasing it back into the atmosphere. So just don't think because they're underwater they can't do that. They're doing it every day, all the time. They produce most of the oxygen in this world for life to exist. Moving on to respiration. So this is when animals convert the oxygen that the plants make, and with the help of glucose, aka sugar, they turn it into carbon dioxide and energy. So we need food and we need oxygen in order to create carbon dioxide and respirate, breathe. In this situation, carbon gets added to the atmosphere. Carbon gets released into the atmosphere through respiration. Animals breathe in a variety of ways. However, the equation itself is always the same. Oxygen plus sugar will yield carbon dioxide, will also yield water and energy. So there's a diagram over here on the right that shows the different ways that animals breathe, but it's all the same. And moving on to decomposition. So eventually the animal stops breathing and it dies. This is the process in which dead organisms break down into simple nutrients, and microorganisms and bacteria will feed on the rotten remains. Isn't that pleasant? In this situation, carbon is also released back into the environment as carbon dioxide. So as bacteria is chomping away at the dead animal carcass, carbon dioxide is getting put back into the atmosphere. Some materials are not decomposed fully, and they end up as deposits underground. These are fossil fuels. And we can look at the equation down at the bottom here. We have sugar plus oxygen will yield carbon dioxide and water. And this is the process of decomposition. Now, something interesting I want to mention about decomposition is for decomposition to occur, you have to have oxygen present. Because bacteria requires oxygen. Aerobic bacteria requires oxygen in order to decompose things. Now, there's also anaerobic bacteria which do not require oxygen in order to break down things, but those guys are much more rare and the process is slower, and they require methane in order to break down things, and when that happens it smells really bad. So that can happen in the bottom of a lake or a pond or even an estuary. And you can have situations known as hypoxia or eutrophication. But anyway, back to this oxygen thing. Yeah, bacteria need to have oxygen. And sometimes in areas of the earth, like the bottom of the ocean, where there's very little light present and therefore no phytoplankton, therefore not really much oxygen going around, nothing can really break down. So it has to have animals actually break it down. And I'll never forget this professor I had in this biogeochemistry class that I took. And he was telling me how this submarine crashed on the bottom of the ocean, and it was like 30 years after until they finally went down there and were able to check some things out. And they found a bologna sandwich in the submarine, in its bag, in its lunchbox. So they pulled it up to the top of the ocean, and what did they find? That the bologna sandwich was totally fine. A 30-year-old sandwich, and it looked like the day it was made. And that's because in order for decomposition to occur, you have to have oxygen present. And there was no bacteria down there to actually break down the sandwich. So it stayed there. That always stayed with me. Whenever I think of decomposition, I think of that. So I hope it helps you. All right, now we are on to combustion. So this is the process of burning organic material in the presence of oxygen and release carbon dioxide and water and energy. So this is when at our power plants, whether they're coal power plants, whether they are oil, natural gas, even nuclear power plants, release carbon dioxide into the air. And these organic materials contain carbon and hydrogen. Combustion reactions are exothermic, meaning that heat energy is given off. So in this chemical equation, you need the material. So it can also be wood, but this little image here, it can also be oil, natural gas, or coal, and then oxygen. So when these things are burned, they will create carbon dioxide, water, and then energy. And the type of energy it'll create is heat. And then we use that heat to spin the steam turbine, to control the electric generator, to convert the electric generator to the power plants, to our houses. So combustion is part of the carbon cycle, and this is the part of the carbon cycle that we as humans are worried about, because we are producing so much combustion. We are releasing carbon dioxide into the atmosphere at a much higher level than what it is naturally used to. So this is the part of the carbon cycle that we as humans can really control. Now, volcanoes also do this. They also release carbon dioxide. They're burning things and releasing a lot of heat and carbon dioxide. But we are doing this at significantly high levels. All right, now on to weathering of rocks. So we've been discussing for a while about that magical rock known as limestone. Limestone has calcium carbonate, which is CaCO3. And limestone is a chemical sedimentary rock. That's very important, guys, because what happens to limestone is when it's exposed to rainwater, which is naturally acidic from carbonic acid that we discussed in our last unit, the rainwater erodes limestone away and creates these huge caverns and cracks and crevices inside of the ground. And this carbon dioxide gets, when the limestone reacts with the carbonic acid, carbon dioxide gets released. And so we can look at this equation here. When water, like rain, precipitation, mixes with carbon dioxide in the air, it then comes down as carbonic acid. So this H2CO3 is carbonic acid. And like I've told you before, rain naturally does this, and rainwater is naturally acidic. And when it mixes with limestone, it dissolves limestone, because limestone dissolves when exposed to an acid. Marble does as well. Marble is the metamorphic form of limestone. And all this type of vocabulary should be a little familiar with you at this point. So caves are composed of limestone, and they dissolve when they get exposed to the H2CO3. And when this reaction happens, the CO2 gets released and then goes back into the atmosphere and releases a surprisingly amount of carbon dioxide, because limestone is a very common rock. It's usually under the ground because of ancient oceans that used to be there. Remember, limestone is composed of ancient plankton from millions of years ago, and it gets compacted and cemented, and then as the plate tectonics move, it no longer is on the bottom of the ocean, but now under land, like where we are. There are caves all around New England and all around the United States. Time to summarize. All right, so let's take a look at all our different things we talked about today. So we have photosynthesis. That is when the plants take in the carbon dioxide. So you can see the down arrow here. It's taken in the carbon dioxide and turned into oxygen. And then if you look at most of the other arrows, they're kind of going up back into the atmosphere. So primary consumers will eat the plant. And then I remember last year we argued whether this is a bobcat or a lynx. Go ahead and comment on this video what you think it is. I am curious. But anyway, the higher level consumer eats the primary consumer, which eats the plant. But they all respirate, and that goes into the atmosphere. And then we have the detritus, which is the decomposition part of it. And that is decomposing all these things that die and sending it back to the atmosphere as well. And then last we have the combustion here from the factory, the red factory in the background, and it is burning wood or fossil fuels, sending carbon dioxide back in the atmosphere by burning the fossil fuels. And last, it's not mentioned here, but maybe we can pretend that there's a cave over here and there is H2CO3 dissolving the limestone, which is causing a chemical reaction and CO2 to go into the atmosphere as well. So please guys, draw some sort of diagram like this, label it really well, even add some notes that I've been talking about now, because that's going to be your best way of understanding the material and putting it all together. Alright, here is the summary. You need to be able to answer these three questions. What processes release carbon into the atmosphere? What processes absorb or take in the carbon from the atmosphere? And why is photosynthesis such a critical process for all living things and not just plants? So I want you to be able to answer these three questions, with words, not just quick bullets. Actually answer these questions well as best you can. You should be able to handle that. I will be checking that for homework. Credits for some of the material in this carbon cycle video goes to Leslie Joseph. Alright guys, that's all I have for you on the carbon cycle. Now that wasn't so bad, was it? In fact, I think that was my shortest video. So I have two videos for you to help you review the carbon cycle. The first one on the top right is from Earth Science Week, and it's a great video that will help you review the carbon cycle. Please make sure that you watch that video. And on the bottom left, I have our buddy from Crash Course. He's going to give a nice explanation of the carbon cycle as well. So always remember guys to please subscribe to WasleyScience, and thanks a lot and take care. Thanks. Oh, that's it, I'm done.